I'm going to show you 4 different experiments that use electrical energy or electricity. The first one is, what is an electrical circuit? You are going to see all the different parts that are put together and they make a system. And a system is different things working together. In this case, it's going to be an electrical circuit. Then I'm going to be showing what is an electromagnet. It's a fascinating science tool because it's combining the power of magnetism and electrical energy. The other experiment is about the different forms of energy changing from one form to another form. For example, you have any appliance, let's say you have a hair dryer. It doesn't work until you plug it into the wall outlet. And once the electrical energy comes into the hair dryer, it will change to different forms of energy, and one of them is heat energy and wind energy for drying up the hair. And finally, the fourth experiment is the 4 sources of electrical energy. There are many sources or where we can get the electrical energy from. In this case, I'm going to show you 4 different sources to produce or to get electrical energy. Are you ready? Okay, let's go. This is an electrical circuit because it's made of different parts. It is not working right now, so we'll put together the rest of the parts. So the tiny light bulb goes here and needs to be connected to the power source, which is right here. So what we do now is we plug it in, and this electrical circuit is still not working because I need to push the switch to turn this system on. So in this moment we can say that the electrical circuit is not working because it is open. And open means there is a disconnection and the electrical energy does not flow. So from open, I'm going to close it, and here we go. 1, 2, 3. Now the electrical circuit is on because it is closed. Now I'm going to show you another type of electrical circuit. This is made of different parts: the battery, the wires, the switch, light bulb holder, and the light bulb. And if you can see, the electrical circuit is open because the switch is up. So it is disconnected, and this electrical system is not working. So it's going to work just by doing this. The electrical circuit is closed, it's on, it's working. Now the switch is up, electrical circuit is open, it's disconnected. Before I show you an electromagnet, I need to explain this to you. Here we have 5 different things. All of them are metals, different types of metals. And let's see their physical properties. This is an iron nail. This is a fishing weight made of lead. This is a copper penny. This is an aluminum nail. And this is a brass key. All of them are metals. And if we test them with a magnet, we are going to see that lead is not magnetic, copper is not, aluminum is not, brass is not, iron is magnetic. So out of all these metals, only this metal, iron, is magnetic, which means it's going to be attracted to a magnet. Remember that the magnet has an energy called magnetism. And the magnetism is going to be pulling the magnetic object. In this case, the magnetic metal, like this. So we can say that the rest of the metals are not magnetic. But if we are going to be testing if they are conductors of electrical energy, it's a very different story. Because we have here a very basic electrical circuit, and I can put from here to here this object, and I can show you the light bulb turns on. And the same thing is going to be happening with all of them. If I put an iron nail, the same thing with all of them. Now, the electromagnet is going to be one thing that combines these two energies. Very interesting. Here we go. We need the power source. We need the metal that is going to be magnetized. In this case, this iron nail is magnetic, but it's not a magnet. As you can see, it's not a magnet. This is an iron washer, and the iron washer is magnetic. So right now, this iron nail is not magnetic. We are going to make this a temporary magnet. So all we have to do is within a wire, we coil it around, or we wrap it. We wrap the nail, and just by doing this, okay, it's right there. Now, the electrical energy, once I connect this electrical circuit, we have to be careful in this case because many times the electrical energy hits up very quickly and you can burn yourself. So make sure that this experiment has to be done with adult supervision. So look, it's not magnetic, and now 1, 2, 3, it is a temporary magnet. Now the iron nail is magnetized, it became a temporary magnet. I'm going to disconnect the electrical circuit, and 1, 2, 3. Now it is not a magnet anymore. That's why an electromagnet is a temporary magnet. And this is a permanent magnet. This experiment is about changing forms of energy. I have a lamp here, and this lamp is changing the incoming electrical energy to heat and light energy, as you can see. In a moment, the solar panel that is designed to be used for sunlight, but there are some types of light. In this case, I have a halogen light bulb that produces the light that makes the solar panel work. So once I turn this light bulb and it's shining the light on this solar panel, the solar panel changes light energy to electrical energy. The electrical energy will reach this tiny LED light bulb, and it will change from electrical energy to light energy. And at the same time, I have connected here a buzzer, which is going to be buzzing, which means it's going to be producing a sound. Okay, let's put all this system to work. The different forms to get electrical energy or sources of electricity. This light bulb will not turn on unless I connect it to the power source, which is coming from the wall outlet. You know, power plants are burning fossil fuel somewhere there, and through the utility grid or the city electrical system, the grid that brings the electricity to schools, homes, businesses, etc. And finally, the electricity comes here. So this is the source number one, the wall outlet. So we connect it, and thanks to the electrical energy, we turn this thing on. Another way to produce electrical energy is by using a solar panel. This is another solar panel, and I have this tiny light bulb. This light bulb will not turn on unless it receives the electrical energy. Well, look what the solar panel does. Another source of energy is from a battery. Store energy in a chemical form inside a battery. So let's produce electrical energy to turn on this light bulb. 1, 2, 3. And finally, we're going to produce electrical energy to turn on this light bulb by using a generator. Generators have a little motor here, but you need to move different parts in order to produce electrical energy.